Day 117 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem, but you already knew we would be here, just like I knew y'all would be here, because we're all about staying consistent and staying disciplined, y'all. So I'm glad y'all are here, and I'm glad y'all ready for this. I hope y'all are ready for this LeetCode problem of the day. But before we get started, don't forget, bring a mouse right over here and click that subscribe button for me, y'all. Then after you click that subscribe button, go ahead and smash that like button for me, y'all. Then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we could run up this engagement and we could do our part in helping to get this content out to a broader audience so we could help build the Swift community as a whole and get more people interested in learning about the Swift programming language, y'all. Now, with all that being said, I know why y'all are here. And today we have question number 2418, sort the people. The difficulty level is easy, so y'all already know we're going to keep the solution as simple and easy to understand as well, because we're all trying to learn here, and it's going to be kind of hard to learn if you don't understand what it is that you're coding. So let's get into the question and see what the question says. It says you are given an array of strings, names, and an array heights that consist of distinct positive integers. Both arrays are of length n. For each index I, names I, and heights I denote the name and the height of the ith person. Return names sorted in descending order by the people's heights. So let's break that down. Let's look at these examples so we can see what they mean. So first we have an input of names. That's an array of strings, Mary, John, and Emma. It also has an input of heights, which is an array of integers, 180, 165, and 170. The output is Mary, Emma, and John. The explanation, Mary is the tallest, followed by Emma and John. So each one of these names at the index has a corresponding index for their height. So Mary is at index 0 right here in heights. Heights has 180 at index 0, so that means Mary's height is 180 inches, right? John is at index 1, then 165 is at index 1 of heights, so that means John's height is 165. Then Emma is at index 2. Then we have 170 at index 2 of heights. That means Emma's height is 170. And we want to rank these people in order by their height, right? So Mary is the tallest, so we're going to append Mary first, right? Then after Mary, Emma is the second tallest, so we're going to append Emma right here. Then John is the third tallest, so we're going to append John right here. And that's why it goes Mary, Emma, John, because these are the corresponding heights. So let's look at example 2 just so we can really make it make sense, just in case that didn't make sense for some people. We have input names that equals an array of strings, Alice, Bob, and Bob. The heights is an array of integers, 155, 185, and 150. And the output should be Bob, Alice, Bob. The explanation says the first Bob is the tallest, followed by Alice and the second Bob, right? So don't let these 2 Bobs confuse you. They're still 2 different people. And let's break it down. So Alice is at index 0. We have 155 at index 0. That means Alice is 155 inches. Then we have Bob at index 1. Then we have 185 at index 1 of heights. That means the first Bob is 185 inches, right? Then we have the second Bob at index 2, and we have 150 at index 2 of heights. That means the second Bob is 150 inches. And we want to rank these people from tallest to shortest, right? So right here we have Bob at 185 inches. So he'll go first. He's the tallest. We'll put Bob right here. Then we have Alice. Alice is 155 inches, so we'll put Alice second because she's shorter than Bob, but she's shorter than the first Bob, but taller than the second Bob because the second Bob is 150 inches. So we're going to put the second Bob right here, and the output should be Bob, Alice, Bob. And that's how they got that output. So now that we understand the question, let's get into the fun part, the part you've all been waiting for, y'all. guess what, y'all? Guess what? We got a one-liner. So yeah, we could solve this problem in one line of code. It's not that difficult to understand at all. I'm gonna break it down for y'all. So let's get into it. The first thing we are going to do is we are going to say zip, then we're going to say names, comma, height. And what that is going to do is it's going to create an array of tuples, kind of like a zipper. Like when you're zipping up your coat, you start from the bottom. First you do, I don't know which one comes first, but it'll go the left zipper, then the right zipper, then the left zipper, then the right zipper, then the left zipper, then the right zipper, all the way till you get to the top of the coat, right? It's the same thing. This works the same way. First we're gonna do, so what we're doing is we're zipping the names and the height, right? So first it's gonna do Mary, then it's gonna do 180, then it's gonna do John, then it's gonna do 165, then it's gonna do Emma, and then it's gonna do 170. And what that is going to look like, let me show y'all what it looks like so you can see better. It's gonna say Mary, then it's gonna say comma 180. Excuse me. That's gonna be the first tuple. Then we're going to come out here, and then it's going to say Emma. Then it's going to say, how tall is Emma? Oh, no. Then it's going to say John, because we're up here. We're going up here, right? So then it's going to say John. Then it's going to say 165, right? So we're going to come right here. It's going to say John 165. Then it's going to come over here. Then it's going to say Emma, and it's going to say 170. So it's going to go Mary 180, John 165, Emma 170, right? That's what this does right here, right? Now, once we have broken it up into the tuples that we want, like so, then we're going to sort them, right? And we're going to sort them by saying dot sorted, open up the brackets, we're going to say $0.1, then we'll say it's greater than $1.1. So with this $0 is going to represent each tuple, and this $1 is going to represent the next tuple, kind of like if we were doing a for loop of a for I and up to names dot count, and a for j up to names dot zero up to names dot count. It's similar to something like that, right? So this 0 is going to represent the first tuple, then this is going to represent the other tuples. So the $0s, they represented, or the $1, the $0 and the $1, they represented the whole tuple. So $0 going to represent the whole tuple, $1 going to represent the next tuple, right? And then so this 0.1, this is going to represent the second element in the tuple, right? So it's going to sort them by the second element in each tuple, which in this case is the height. So the 0.1 is what allow us to separate or to sort the tuples by height. And the new tuple will look something, or the new array of tuples will look something like this after we sorted them, right? So first it'll say we'll have the Mary, because Mary's the tallest, right? So we'll put the Mary right here, boom. Then we'll have the Emma, because this is sorting the whole tuples. This is sorting the tuples by height. I mean, yeah, not just the heights. It's sorting the whole tuple. Then we'll have the John. Then we'll add John right here. Boom. So we could delete this one. So this right here is going to get us this right here, right? But remember, we only want the names. We don't want the name and the height, right? So now we have to map it by the name. So to do that, we're going to say, come over here, we're going to say dot map, open up the brackets again, and we're going to say $0 for each tuple, 0.0. And this 0.0 represents the names. The 0.1, that's going to represent the height, but the 0.0 is going to represent the name. So we're gonna map it by the names, right? So we could delete this, or really it's just gonna get rid of the heights, right? So we could get rid of the heights right there, and the new output will look something like this, right? Except without the parentheses. So we could get rid of the parentheses. So that's what the final output should look like after we map it by height. So let's get rid of this, because that was just so I could break it down as a visual representation for y'all. Now that we know what the code is doing, let's run it. Make sure it runs like it's supposed to, which it should. Let's see. Ooh, heights. It should be heights, y'all, not height. Excuse me. Let's run it again. See how it runs. See how, and there it is, y'all. It's accepted. So let's submit it. Make sure it stays accepted, because you know how that can be with LeetCode. You never know. And there it is. 90 milliseconds beats 9.81% of users with Swift, y'all. Now, not too bad at all. We're not too worried about the numbers, because remember, y'all, we're all learning. We're all trying to learn here. And we need solutions that people can understand. We're not worried about the fancy solutions that's just going to run fast, but nobody understands what's going on. We're trying to learn, and in order to learn, we need to understand what's going on. And I feel like this was a good solution to break down, so we all could leave this video having learned something today. So now that's the LeetCode problem for today, I hope to see y'all tomorrow for another day, another LeetCode problem. Peace.